Hey, welcome to this lesson on vector subtraction using trigonometry. Very simple principle as vector addition using trigonometry with a very slight twist. So the goal here, of course, is to solve problems similar to this. Acceleration problems, where you're given time and you're given two velocities that are in different directions at angles. Okay? Yesterday we did that using components, x and y components. And then in today's lesson, we're going to do the same problem with a different approach, which is using trigonometry and drawing a triangle. Essentially, just to remind you, the time part, the scalar, comes in at the very end of the problem. It's not really that relevant as far as the vector subtraction, so we'll worry about that later. And our focus is going to be on this vector subtraction here. Now, the whole principle about vector subtraction using trigonometry is using the idea that v2 minus v1, as in any bit of integer math you've ever done, you would know that v2 minus v1 is the same as saying v2 plus negative v1. So, if we want to use the exact same strategy, the exact same triangle method, trigonometry method that we used with vector addition, you can do that by adding, instead of subtracting v1, we're going to add the negative of it. So then the whole new part of today's lesson, is about figuring out what negative v1 is. And it's actually very, very simple. So you can start a new heading on your page called negative vectors. I'm going to show you how to find negative vectors. This will be instinct for you. For example, if I was going to say v1 equals 1 meter per second north, then I was going to sketch that. It would look like that. Well, negative v1 would be this. 1 meter per second south. The total opposite. Sketch it. Completely opposite. Okay? Quite simply. If I said v1 equals 1 meter per second east, negative v1, you can probably guess, would be 1 meter per second west. So there's v1, there's negative v1. So in the case of just east, west, north, south, very, very simple. It doesn't get much more complicated than that. Let's just erase the page and look at negative vectors when you have an angle. So I'll do my coordinate system in the middle here. And in this case, let's say v1 equals 1 meter per second, 45 degrees north of east. Okay, here's my v1. My negative v1 probably won't surprise you to know that the negative of v1 is going to be down here. And as far as the angles are concerned, if you think back to grade 9 opposite angle theorem, if you know this angle and this angle are going to be the same, just like those two are going to be the same. So if this is 45 degrees, this is 45 degrees. So negative v1 then equals 1 meter per second. You never change, you never make a negative sign. 45 degrees south of west. Just making a little connection here. These are the same, these are the same, those are opposite, those are opposite. Okay, let's just do one more example to give you something. 45 degrees is a little bit symmetrical, so it's not the best example, maybe to start. But let's do one that's just a little bit different, and you'll realize how simple it is. This time, let's say up here, v1 equals 1 meter per second, 60 degrees north of east. And if I drew my negative v1, it would be down, just basically extend a straight line, 1 meter per second. Again, looking at my angles, if this is 60, this is 60. So it's going to be 60 degrees south of west. Again, making a connection, north becomes south, east becomes west, and that's it. Everything else stays the same. So just to go run through a bunch really quick, if V1 equals 1 meter per second, 50 degrees west of north, negative V1 would be 1 meter per second, 50 degrees east, opposite. If V1 was 10 meters per second, doesn't matter what the number is, that's for sure, 20 degrees south of east, negative V1 would be 10 meters per second, 20 degrees north of east. Okay, and of course I keep using velocities, but it doesn't have to be velocities, it could be force, it could be displacement, it could be anything. So that's negative vectors. So now let's do an example calculating acceleration using trigonometry. I'm just going to get rid of this title too for more space. And instead of writing out a scenario, I'll just give you some vectors and the time, and we'll solve acceleration. So in this question, we have V1 equals 10 over and we're given a time of 10. Okay, so this object accelerates from 10 meters per second, 40 degrees north of east, to 15 meters per second, 10 degrees south of east in 10 seconds. And of course we're looking for that's the point of the question. Well, the very first thing I'm going to do is identify negative V1. Because, again, using the formula, A equals V2 minus V1 over delta T really turns into A equals V2 plus V1. Okay? So given our time, we need to identify negative V1. Okay? And it's fairly simply just negative V1, don't have to sketch it, just change the signs. Negative V1 is going to stay at 10 meters per second, that doesn't change, but it's 40 degrees south of, okay? So, let's go ahead and draw a triangle and do the trigonometry. So V2 was 15 meters per second, 10 degrees south of east. So I'll start with the coordinate system. And my 15. And the angle right in here is 10 degrees. Okay. From here, I have to add negative V1. So again, I'll draw another coordinate system. And to the end, this tip of my vector, I'm going to add 10 meters per second, 40 degrees south of west. So that's going to be in this direction, south of west. And 10, so it'll be about that long. And this time, 10 degrees. Okay. My resultant vector, my delta V, if you will be from the very beginning to the very end. I'm going to call this delta V. Okay, that's what we're looking for. Now we have a triangle, we have two sides, we don't quite have two angles yet, but we're close. And here's how you get this angle right here, because I want to know the angle opposite to my V. I've got this 40. What you do is you can use the fact that this is 10 degrees in here, use my Z law, I'll draw out my Z, to realize that this must be 10 as well. So that means that this full angle is 50 degrees. Knowing that, we can just simply apply the cosine law to find delta V, where delta V squared, magnitude only of course, is going to be 15 squared plus 10 squared minus 2. Okay, that's messy. It's 2 times 15 times 10. Again, just cosine law. You can solve that on your own, Or you can trust me that delta V in magnitude is 11.5 approximately. Okay? Going up, just looking again. So if I want to report my delta V with an angle, if I know this part is 10 in here, if I found this right here, we'll call it theta. If I found this, then I could say that delta V is, theta plus 10 degrees south of east. So let's find theta using the law of sines. Basically, sine theta over 10 is going to be equal to sine of 50 over 11.5. And I'll leave it to you to solve for theta. Theta turns out to be 42 degrees. So now I know delta V. I'm going to switch the rest of the answer in a small area. Delta V equals 11.5 meters per second. Okay, watch this. 42 plus 10 degrees south of east. Okay? Remembering the 42 plus 10 comes from the original. It is 42. So this is 42 plus this little bit, south of east. Okay. Finally, I'm not there yet because I need acceleration, but we're really close. Acceleration is going to be my delta V, or V2 minus V1, over time, which is 11.5 over 10. Acceleration equals 1.2 meters per second squared. Get this straight. 52 degrees south of east. And that would be solving for acceleration using vector subtraction and the law of sines and cosines.